So hello students, today we will see how to construct the model from the H parameters equation. So our aim in this video is to construct H parameter model circuit from equations. So we are having the two equations which we derived in the last lecture. The first equation was V1 and the second equation was related to I2, and we know V1 and I2, they are dependent on I1 and V2. So this I1 and V2. So these things were related using H parameter. So this was HI, right? This was HR, this was HF, and this was HO. So these two equations are very important. This is equation 1 and equation 2. We will use these 1-2 equations for derivations of different parameters like voltage gain, current gain, input resistance, output resistance. So always remember these two equations. These equations are very important. These two equations. Very simple equation and very important equation. Now how to construct from these equations, how to construct the actual H parameter circuit. So we know this is input side. This is actually your input side. V1 is representing the input side and this I2 is representing the output side. Now from input side, suppose V1 is there. So this is V1. I am constructing now. This is V1. Is sum of two things. This is the first thing. This is the second thing. What is the first thing? HI into I1. HI into I1. Something multiplied by current. We know our basic equation of resistance. What is that? Ohm's law, V equal to IR. So if anything is multiplied, this is the current. If it is multiplied with something and it is resulting into the voltage, that anything could be a resistance. Yes, it should be a resistance. So it is a resistance. So HI is actually our resistance. We are getting or not? See here, again I am telling you, this is V1. This is voltage. This is voltage. Voltage should be sum of voltages only. Yes or no? Voltages only. You can only add voltages to get a voltage. You can't add voltage plus current and get some voltage. No. You can't add horses with donkeys. Yes or no? So voltage is actually your voltages plus voltages. So this term must be voltage. This term must be voltage. So what I am telling you, this V1 is HI plus HI into I1. So this whole term is voltage. Yes, I agreed. Now I1 is multiplied by something to get voltage. Means what? HI should be input resistance. So what I am writing here? This HI as a resistance. And of course the current is I1. So HI is multiplied with I1. This is the first term we will get. The voltage drop here will be HI into I1. First term is over. Now second term is what? HR into V2. Now this is voltage V2. What is V2? It is somewhere at the output. Somewhere at the output I can draw here. When we will see the output side, we will draw that V2. So this is your V2. So this is your V2. So this V2 multiplied by HR. So what is that? What is that thing? It is some V2's proportion is taken. That proportion depends on HR. So it should be a dependent voltage source. So I can draw here dependent voltage source. its value is HR into V2. That's all. That this is the input side. If you apply the KVL here, what you will get? V1 is equal to I1 into HI plus HR into V2. That's all. Over. That input side is over. Now at the output side, what it contains at the output side? I2. So I2 is actually this current. It is HF into I1 plus H0 into V2. So if you see HF into I1 means what? This is current. Again I am telling the same thing. This is current. So current should be the combination of two currents. So this must be a current and this term must be a current. That's sure. So this term I1, this is I1 multiplied by some quantity HF means what? It should be a dependent current source. So I am drawing this dependent current source. So this is dependent current source. Its value is HF into I1. The second term must also be a current, H0 into V2. So what should be H0? What should be H0? It should be a resistance, right? Because H0 is what? I2 by V2 when I1 is 0. So what should be H0? See, you know I is equal to what? V is equal to I into R. Just see here. V equal to I into R. So I is V into 1 over R. V into 1 over R. So this 1 over R, actually this is current. It is V. So 1 over R should be your H0, right? So we can write here H0, which is nothing but actually the impedance. So 1 over R, as it is 1 over R, we can write it as impedance, admittance, inverse of the impedance. We are writing it in mhos. So your value will be V2 into H0. These two currents are there. The first current and second current. Like this we are constructing the H parameter model.